Hey, boys and girls, this is day 11 of our math review, and today we're going to cover several things. We're going to review whole numbers and how they relate to fractions, so relate fractions and whole numbers. We're going to compare fractions with the same denominator, so the number that's on the bottom, and then we're going to compare fractions with the same numerator, which is the number that's on the top of the fraction. But before we get started, we're going to go ahead and take a look at our problem of the day. So our problem of the day shows Peggy ate one piece of the pizza that is partitioned below. What words can be used to describe the part that Peggy ate? So take a very careful look at this picture right here. How many parts is this pizza divided into? This pizza is divided into 4 equal parts. Very good. So what would one part of this pizza represent? It would be 1/4. Very good. So now we're going to go ahead and move into our lesson, relate fractions and whole numbers. So it says use fraction strips to complete the fractions. Draw to show your models. So if we take a close look, it's asking us to divide this fraction into fourths. So that's what we're going to do. We're going to start here in the middle, draw a line right down the middle, and then between 0 and this midway line, I'm going to draw another halfway mark, and in between this midway and that, we're going to draw another tick mark. So now we've divided it into 4 equal parts, 1, 2, 3, and 4. So if this is 0/4, 1/4, 2/4, 3/4, then this should be 4/4. So what is our fraction? 1 equals 4/4. And now, same thing, it's asking us to divide into fourths right here. So I'm going to go ahead, same as before, divide it in half, and then divide those parts in halves. So if we take a look, now what is 2 equal? Blank over 4. So remember, this is 0/4. This is 4/4, because 4/4 is equal to 1 whole. So this would make it 5/4, 6/4, 7/4. So that means 2 is equal to 8/4. Good. So how many fourths did you use to model than you did to model 1? To model 2 than you did to model 1. So we had 1, 2, 3, 4 fourths, 5, 6, 7, 8 fourths. So all we did was just add another line of fourths. So if we take a look right here, it says how many fourths would you need to model 3? So all you have to do really is extend this line . Now that's not a perfect line, but we extended it. So 2, and so that means this is going to be 3. So 9/4, 10/4, 11/4, 12/4. So that's how we complete that fraction right there. Let's go ahead and think and grow equivalent fractions and whole numbers. So they've given us a couple of examples to take a look at. We're going to look at the first example. Write the numbers 1 and 2 as fractions. The number line shows 2 wholes. So I see 1 whole and 2 wholes. Each whole is divided into 1 equal part. So 1 whole divided into 1 equal part can be written as 1/1. 2 wholes each divided into 1 equal part can be written as 2/1, because that's 1 part and 2 parts right there. So 2 wholes each divided into equal parts can be written as 2/1. So therefore, 1 equals 1/1, And 2 equals 2 over 1. And if we think about it, division-wise, 2 divided by 1 equals 2. Our next example uses equivalent fractions. So write equivalent fractions for the numbers 1 and 2. So I see 0, 4, 1, 4, 2, 4, 3, 4. So what goes right here? 4 fourths, very good. Then we have 5 fourths, 6 fourths, 7 fourths, 8 fourths. Nice. All right, down here, it's been divided into halves. So 0 half, 1 half. There you go, 2 halves, 3 halves, and that would make 4 halves. And if we take a close look, before we get started, I want to just show you 1 over 1 equals 4 divided by 4 equals 1. 8 divided by 4 equals 2. 2 divided by 2 equals 1. And then 4 divided by 2 equals 2. And I hope you guys can see that. So 1 equals 1 over 1. 2 over 2. And 4 over 4. 2 equals 2 over 1. 4 over 2. And so what they've done is they've taken this, what they're trying to show us, and it's increasing. Do you notice that? 1, 2, 4, 1, 2, 4. So 1 times 2 is 2, 2 times 2, 4. Same thing right here. 2 times 2 is 4, 4 times 2 is 8. So we have 2 over 1, 4 over 2, and 8 over 4. And this is pretty much where we got our information from, right there. Show and grow, show me what you know. So complete the number line, then complete the statements. So if I take a look, I see my denominators already there for 6, and then this one shows thirds. So with our 6 denominators, this would be 6 over 6, because 6 over 6 equals 1. 7, 6, 8, 6, 9, 6, 10, 6, 11, 6. That would make this 12, 6. Very good. And then down here at the bottom, we have thirds. 0 third, 1 third, 2 third. That means this would be 3 thirds. 4 thirds, 5 thirds. That would be 6 thirds. So 1 equals 1 over 1, 3 over 3, or 6 over 6. Because remember, a number over itself is always going to be equal to 1. Now let's take a look at our 2 whole right here. So 2 equals 2 over 1, 6, right here, it shows us right there, 6 over 3, and then 12 over 6. So literally, if you take a look, a nice close look, here are 1, 3, 6. So they did 1 times 3 is 6. 1 times 3 is 3, and then 3 times 2 is 6. And then right here we have 2 times 3 is 6, and then 6 times 2 is 12. All right, apply and grow. So at this time, I don't think this should be too difficult for you guys to complete because they've done the majority of the work for you. So we know that the denominator at the top is 8. So of course you can just go ahead and fill in those 8s. Right there. And then the denominator at the bottom is fourths. So just go ahead and write in your fourths. Now, like I said, the majority of the work has been done for you. So this problem should not be that difficult. So at this time, I want you to go ahead and fill in the remainder numbers that you have right there, the remaining numbers that you have, 4 fourths, the fourths and the eighths, and then we'll be able to complete the one down at the bottom. So of course, the 16, 17, 18, then 20, 21, 22, 23, 25, 26, 27, 28, 29, 31. All right, and then of course we have 8, 10, 11, 13, 15. All right, now let's take a look at this. It says 3 is equal to, so of course, we'll start with our 3 over 1. Then we look at our fourths, and what's that number supposed to be? 12. Very good. And then we come to our eighths in that same area right there, because remember, we're trying to make it equal to 3. So in that same area, we look up here, and that is 24. All right, let's go ahead and take a look at the second part of this problem. Number 4, it shows 4 is equal to 4 over 1. Good. And then 4 is equal to, what's that number? 16. Very good. 32. So 32 over 8 is equal to 4. Think about it. 32 divided by 8 equals 4. 8 times 4 equals 32. So now it's asking us to write 2 equivalent fractions for the whole number. So if anything, take a look right here. 2 is equal to blank over 3. What divided by 3 equals 2? So if I do 2 times 3, and that's what I'm thinking in my head, and I want you to do the same thing, 2 times 3 is going to equal 6. So 6 divided by 3 is going to equal 2. So 2 times 6, what number can I write up here to equal blank divided by 6 equals 2? That's going to be 12, right? Now, take a look at number 4. So 1 equals what over 2? 2 divided by 2. 2 over 2 equals 1. And then this one should be simple enough. 3 over 3 equals 1, 3/3. Take a look at number 5. 3 is equal to 3 over 1. Remember, 3 divided by 1 is 3. And then what times 3 times 2 equals what? 6. Good job. Write the equivalent whole number. This is all you're doing is breaking it down, just like I said. So you're dividing. So 16 divided by 2. And what they did was they reduced it. This is something you'll be learning in 4th grade, how to reduce your fractions or simplify your fractions. So 8 over 1 is also going to be equal to 8. Number 7, 4 over 4 equals 6 over 6, which equals 1 whole. Then we've got 16 over 4. It's been simplified to 12 over 3, which is equal. So 16 divided by 4 and 12 divided by 3. They both are divided by that same number, which equals 4. Now, you can cut a sandwich into 4 pieces. You eat the whole sandwich. What fraction of the sandwich do you eat? So I know my denominator is going to be 4 because the sandwich has been cut into 4 pieces. You eat the whole sandwich. So how many pieces are there? Whole, that is 4. So what fraction of the sandwich do you eat? 4 over 4, which also equals 1. Let's go ahead and take a look at question number 10. So what I have done is I have taken the liberty of drawing this all the way out for you to make it simple and easy for you to determine the answer. So if you take a close look, what I've done is I've done these in different colors. So the question is asking, write 3 fractions that are equivalent to 6 using the denominators 1, 2, and 6. And what I have done is I have done just that for you. I have literally labeled out the twos, the denominators for twos. I've written out, well, almost written out. I broke it down a little bit more because I wanted you to take a closer look and figure out what goes in between here. And then, so those are for the halves. And then, there's the halves, those are for the sixths. And then down at the bottom, I did the ones as the denominator. So if we take a look at number 10, what three fractions that are equivalent to 6 using the denominators 1, 2, and 6? So all we have to do is come right over here and take a look. So what are the fractions for number 10 that we would write? So my first one, because remember it has to be 6 is equal to these fractions. So 6 is equal to, our first denominator needs to be 1. So that means it would be 6 over 1. And what I'm going to do is I'm going to move this down just a slight bit. So I don't have to rewrite it again. All right, our next set is 2. So if we come over here and take a look, what is it showing us? Because remember, it has to equal 6. That's correct. 12 halves. All right. And then what is it saying for our denominators with 6? 36. And I promise that's a 3. 36, 6. If you just look very closely, these numbers, once they divide into one another, they all equal 6. Now, question number 11 is asking, use a number line to show 5 over 5 equals 1. Now, I've already pre-drawn mine out. So here's 0 and here's 1. So at this time, I want you to go ahead and pause the video, copy down my number line, and then represent 5/5 on that number line. I'll be here when you get right back. All right, good job. So I noticed that you have gone ahead and completed your number line. This should be 1/5, 2/5, 3/5, 4/5. And then of course, we have our 5/5 right here. So 5/5 is equal to 1, just as question number 11 was asking us to use a number line to show that. All right, now we're moving on to our next lesson, comparing fractions with the same denominator. Now this lesson should be a piece of cake. It should be easy with no problems, because when we look at the denominator, it really helps us to see when our denominators are the same, then we really just have to look at the top numbers. But let's go ahead and get into our lesson, and then I'll be able to explain it a little further. Color to show each fraction. Circle the greater fraction. So we already know how I do. I don't color the whole thing in. So this one's asking me to represent 1/4, and the second one is asking me to represent 3/4. So which fraction would be greater? I colored in 3 parts to 1 part, and it shows that that's greater. So 3/4 is greater than 1/4, or if we read this correctly, 1/4 is less than 3/4. Then of course, down at the bottom is asking for 5/6. So I'll shade in my 5 parts. And then our second fraction is asking for 2/6. So which one would be greater, 5/6 or 2/6? If you said 5/6, you are correct, because 5 parts shaded in is greater than the 2 parts shaded in. Because remember, our denominators are the same. So that means 5/6 is greater than 2/6. So at this time, I want you to go ahead and pause the video and speak with somebody at home. How can you compare fractions with the same denominator? All right, let's find out if you're correct. Think and grow. Compare fractions that have the same denominator. We have 2 examples that are being presented to us. We're going to take take a look at the first example. It says compare 3/8 and 7/8. Use fraction strips. The fractions have the same denominator of 8. So 3/1/8 is 3/8. 7/1/8 is 7/8. Shade the fraction strips. So we're going to do that at this time. So it's asking for 3/8. So I'm going to color in 1, 2, 3/8. And then the second one is asking for 7/8. So I'm going to color in 3, 4, 5, 6, 7. So more 1/8 are shaded to show 7/8. So 3/8 is less. We'll just go ahead and use the mouse. It's going to be a little nicer. Less than. So 3/8 is less than 7/8, and 3/8, remember, we always eat the bigger fraction, just like when we were comparing numbers, eat the bigger fraction, the greater eats the bigger fraction. So 3/8 is less than 7/8. And another way to show it is when the denominators are the same. This is what I was talking about earlier. When the denominators are the same, the whole is divided into the same number of equal parts. So look at the numerators, 3 and 7, to compare. The fraction with the greater numerator, or the greater number, is the greater fraction. So because 3 is less than 7, made a mistake there, 3 is less than 7, 3/8 is less than 7/8. So let's go show and grow. Show me what you know. So right now it's asking us to shade in these parts. So we see 5, 6. I'm going to shade in 5. 1, 2, 3, 4, 5. And then the bottom's asking for 2 parts shaded in. So 5, 6 and 2, 6. Which one is greater? That's correct. 5, 6. So we're going to eat 5, 6 because it's the bigger fraction. Let's do number 2. 1/3 and 3/3. So I'm going to color in just 1 for the top, and at the bottom, it's asking for 3/3. So which fraction is the bigger fraction? 3/3 is correct. So we're showing 1/3 is less than 3/3. We're going to eat the bigger fraction. So I want you at this time to go ahead and complete number 3 and number 4 on your own, because I know that it's just so simple, so easy for you to be able to do. Go ahead and pause the video. I'll be right here when you get back. All right, welcome back. So for number 3, your answer should have been 5/8. And for number 4, your answer should have been equal. Now I know you're probably going, well, how are they equal, Ms. Green? Well, 2/4 and 2/4, those are equal fractions, because if you did this correctly, it shows that you shaded in the same amount of parts right there. Let's take a look at number 5. Now, let's forget that we have the denominators, and let's go ahead and look at the numerators. So we're going to compare the numerators to figure out the answer. So for number 5, which fraction would be greater, 2/3 or 3/3? So which number is greater, 2 or 3? Since 3 is greater, we're going to go ahead and eat 3. So 3/3 is greater than 2/3. Number 6, same thing. We have 1/2 and 1/2. Obviously, that should be easy. 1/2 is equal to 1/2. Take a look at number 7, 3/8 and 1/8. Now remember, we're taking away the denominators. Go ahead and look at the numerators. Which number is greater, 3 or 1? That is correct. 3 is greater. Now at this time, I'm going to pause the video. Now I want you to go ahead and complete the remainder of this page. All right, welcome back. Let's take a look at question number 11. Which statements are true? So when it says which statements are true, that means there's going to be more than one correct answer. So 2/3 is showing 2/3 is less than 3/3. Is that correct? That is. So we're going to circle the first one. 3/4 is greater than 2/4. That is also correct. 5/6 is greater than 1/6. Yes, it is. And then 2/2 is greater than 1/2. No, go ahead and cross that one out. Doesn't make any sense. So how can you show that 3/8 is less than 6/8? So at this time, I want you to go ahead, pause the video, and write your answer with everything we've just been practicing. How can you show that 3/8 is less than 6/8? Go ahead, pause the video. I'll be right here when you get back. All right, welcome back. So I'm hoping you said something along the lines, well, if I draw out the 8 parts for the 3/8 and the 8 parts for the 6/8 and shade them in, you'll be able to notice that 6/8 has more parts shaded in than 3/8. Or you could have said something along the lines of, I just look at the numerators and I know that 6 is greater than 3. So right there, both of those answers would have worked. Question number 13. Which statement correctly compares the fraction of circles shaded in group A to the fraction of circles shaded in group B? So I know for group A, I see 1, 2, 3, 4, 5, 6. And then for group B, I see 1, 2, 3. So I want you to go ahead and answer that question on your own. I don't want to help you with that one because I know you can do it. Go ahead and do that at this time. All right, now we've moved on to Think and Grow, modeling real life problems. So Newton and Descartes have the same number of chores. Newton finishes 2/3 of his chores. Descartes finishes 1/3 of his chores. Who finishes more of his chores? So what I've already done is I've taken the liberty of pulling out rectangles and divided them into thirds because I have to model what that will look like. So Newton did 2/3 of his chores. So we're just going to cross out 2 parts of that. And then Descartes did 1/3 of his chores. So who completed more of the chores? Who finishes more of his chores? If you said Newton, you are correct. So I want you to go ahead and write your explanation below of why Newton finished more of his chores. Go ahead and pause the video. I'll be here when you get back. Okay, let's go to Show and Grow. I can think deeper. At the pet store, a green lizard is 5'6" long. So I'm going to go ahead and write 5'6". A brown lizard is 6'6" long. So you pick up the longer lizard. Which lizard did you pick up? So at this time, I want you to go ahead and compare and answer that question on your own. So you'll circle the green lizard or the brown lizard. All right, question number 15. You and a friend each have a burrito. The burritos are the same size. You eat 3/4. Wow. You eat 3/4. That means you were very hungry. And your friend eats 1/4. So the question is asking, who has less burrito left to eat? Ooh, that is a good question. So remember, you ate 3/4 of your burrito and your friend only ate 1/4 of his burrito. So I think this would be a great time to go ahead and draw that out and then decide from there who has less left to eat. And I think you'll be able to figure out the answer once you have drawn it out. At this time, I'm going to go ahead and pause the video, and I'm going to allow you to answer questions number 15 and 16 on your own. I'll be here when you get back. All right, we are moving on to compare fractions with the same numerator. So color to show each fraction, circle the greater fraction. So if I take a look, this one, the first one wants me to do 1/8. So I shade in 1/8. This one is asking for 1/3. So which fraction is bigger? Circle the greater fraction. So looking at these pieces, I see that 1/8 is really small, and 1/3 is way bigger than 1/8. So which fraction is bigger? I'm going to have to go with 1/3. Now, if you would like, you can go ahead and discuss with somebody at home how can you use fraction strips to check your answer and draw to show. But what I'm going to do is I'm going to go ahead and move on. So think and grow. Compare fractions that have the same numerator. So we have a couple of examples here to take a look at. So our first example is showing compare 2/4 and 2/6. One way is to use the fraction strips, which they have located right here for us. Both fractions have the same numerator of 2. And if you take a look, the numerator is the top number right there. 2 1/4 is 2/4, as well as 2 1/6 is 2/6. So shade the fraction strips, compare the parts. So for 2/4, I'm going to shade in 1, 2 parts. And for 2/6, I'm going to shade in 1, 2 parts. So if I take a close look, which one is smaller? 2/4 or 2/6? The smaller one is 2/6, so the greater one would be 2/4. So we'll say that 2/4 is greater than, and I'm just going to write GT to represent greater than 2/6. And 2/4, we already said, is greater than 2/6. So remember, if that's the case, we're going to eat the bigger fraction. So another way is when the numerators are the same, which we have seen with the 2/4 and the 2/6, look at the denominators 4 and 6 to compare the sizes of the parts. The more parts the whole is divided into, the smaller the parts are. The fewer parts the whole is divided into, the larger the parts are. The fraction with the greater denominator is the lesser fraction. So in class, I've taught this to you before. The greater the denominator, the smaller the fraction. The greater the denominator, the very good. So 1/4 and 1/6. 1/4 is going to be greater than 1/6, because if we look back up here at the top, you'll see that 1/6 are smaller than the 1/4. So that's why our answer is 2/4 is going to be greater than 2/6. Show and grow, show me what you know. Shade to compare the fractions. So we're going to shade in 3/6, 3 parts of 6, and 3/8, 3 parts of 8. So which one is bigger, 3/6 or 3/8? If you said 3/6, you are correct. So just keep in mind, when we compare the denominators, because the numerators are the same, so we're looking at the denominators now to determine our answer. We're going to look for the denominator that has a smaller number. So I know this might get confusing from time to time, but since this whole lesson is just focusing on the same numerator, we should be able to fly through this with no problem. Look at question number 2. So I'm going to shade in 2/4, and then I'm going to shade in 2/3. So taking a look at the pictures once again, what do we notice? 2/3 is going to be greater than 2/4. So that means 2/4 is less than 2/3. So shade to compare the fractions. I'm not going to assist you with 3 and 4 because I kind of just did. We've been practicing it, so I think you can do that on your own. So at this time, I'm going to go ahead and pause the video and allow you to complete 3 and 4 on your own. Okay, welcome back. Now, if you were using the pictures at the top, the fraction strips at the top, you should have gotten 3 and 4 correct with no problems. But now what I'm going to do is I'm going to assist you with the odd numbers for the compare section. So if I'm doing the odd numbers, that means I'm going to help you with 5, 7, and 9. Okay, so remember, we're not looking at the numerator, we're looking at the denominator, and we're looking for the denominator that has the smaller number, because that means it's going to have the bigger fraction. So number 5, 2/6 or 2/4. If you said 2/4, you are correct. Number 7, 6/8, 6/8. That is equal. Very simple. And then we have 8/8 and 8/8. Once again, they were too nice to us. They gave us the answer pretty much, 8/8. So what I want to do is I want you to take a look. I'll go ahead and assist you with number 10. I had 3/4 and 3/3. Remember, you look at the number that has the bigger, we look at the smaller number, and that's going to help us determine that that's the bigger fraction. So with that being said, 3/4 is going to be less than 3/3. Let's go ahead. I'm going to pause and allow you to complete the rest of that page, number 6 and 8, and I will be here when you get back. All right, so we're going to answer questions 11 through 13. Use the models to compare the two fractions have the same numerators. So if they have the same numerators, that means we can create any way we want as long as it doesn't go past 4. So I'm going to go ahead and just do 3/8 and 3/4. And when I compare these fractions, I can tell you by looking at this model that's over here, 3 parts of 3/4 is bigger than the eighths up here at the top. So that means 3/8 is going to be less than 3/4. So I want you to go ahead, take a look at question 12. You spend 2/3 of an hour playing soccer on Wednesday. You spend 2/6 of an hour playing soccer on Friday. On which day do you spend more time playing soccer? So I do my 2/3 and my 2/6. Now remember, you're looking at the fraction that has the smaller number in the denominator, and that's going to make it be the bigger fraction. So I kind of just gave you the answer. I want you to go ahead and try to complete 12 and 13 on your own. I'll be here when you get back. Go ahead and pause the video at this time. All right, we are at Think and Grow, modeling real life world problems. So Newton and Descartes have piggy banks that are the same size. Newton fills 3/4 of his bank with pennies. Descartes fills 3/6 of his bank with pennies. Whose bank is filled more? So at this time, what I would recommend that you do is you would draw a model like it's asking you to do. So I would divide this into fourths for the first one. Probably grabbed the wrong shape, but I think you have the idea of what I'm trying to do. And then this needs to be divided into 3 parts. And this side needs to be divided into 3 parts. Okay, so at this time, you'll fill in your 3/4 on this side and your 3/6 over here, and you should be able to give your explanation and your reasoning for why you've determined your answer. I'll go ahead and pause the video and allow you to complete that problem on your own. Okay, we're at the end, boys and girls, just 3 more problems. Show and grow. I can think deeper. So you use 1/3 of a bottle of glitter for an art project. Your friend uses 1/4 of a bottle for his art project. The bottles are the same size. Who uses more glitter? So pretty much what you want to do, you can draw out a model, or you can go ahead and write the fractions 1/3 and 1/4. And pretty much the same thing with the remaining problems that are on here. I want you to keep in mind that when our our denominator is smaller, that means the pieces of that fraction are bigger. So that means it's going to take up more space, meaning it is the bigger fraction. So I want you to keep that in mind as you complete number 14. And then if we take a look at number 15, a train and a plane are traveling the same distance from New York to Pittsburgh. The train completes 5/8 of its journey. The plane completes 5/6 of its journey. Which is farther away from Pittsburgh? So if you want, you can draw a number line, or you can even do the model and be able to figure out from right there which one is asking literally for question number 15, which one is actually less than, instead of asking for which one is greater than, because it's saying which is farthest away from Pittsburgh. The greater fraction is going to be closer to Pittsburgh, while the lesser fraction is going to be further away from Pittsburgh. So that's how you're going to be able to determine your answer for number 15. And then if you take a look at number 16, it says dig deeper. You cut a piece of lasagna that is 1/8 of a tray. Your friend cuts a piece of lasagna that is 1/6 of a tray. Your piece is larger than your friend's piece. Explain how this is possible. So if you want, you can go ahead and draw your model. So on one, it'll be 1/6, 1 out of the 6, and on the other, it'll be 1 out of the 8th. Or you don't even have to draw the model, because they just told you that your piece, which is 1/8, is going to be larger than your friend's piece. You cut a piece of lasagna off the tray, your friend cuts a piece. So explain how this is possible, that your piece is larger than your friend's piece. Is that even possible? Yes or no? So at this time, I want you to go ahead and complete question number 16. So literally 14 through 16, I want you to go ahead and pause the video, and I'll be here when you get back. All right, so I want to show you for question number 14, your answer is going to be 1/3. Who uses more glitter? You use more glitter. 1/3 of the bottle uses more glitter. Question number 15, for 5/8 and for 5/6, who is furthest away from Pittsburgh? It's going to be the train that has 5/8, not the plane. Okay, the plane is actually closer to Pittsburgh, but the train is further away. So the train still has some work to do to get to Pittsburgh. And then if you take a look at question number 16, your piece cannot be bigger than your friend's piece. That is incorrect. Your friend's piece is actually bigger than your piece, because your friend's piece, 1/6, is actually actually a little bit bigger than 8s. So I want you to go ahead and explain that reasoning, why they would think that. I think they were looking at that denominator of 8 instead of thinking about what we've been talking about, how if your number is bigger, that means your fraction is smaller. So at this time, if you did not get that correct, I want you to go ahead and fix that problem. But now it is time for Dreambox. I figured I wouldn't do a fraction of the day, give you guys a break. But at this time, if you just go ahead into Dreambox and complete that multiplication or division problems that I have assigned to you, you should be good. Have a great day.